Hi everyone, welcome back to my YouTube channel. My name is ADDIS. Today I'm gonna show you how to solve this problem. As you can see, this problem is all about relative velocity. Before starting today's tutorial, if you are new for educational tips, make sure to subscribe our YouTube channel in order to access every engineering problem solutions and different tutorials that are very important for high school preparatory and university students. Now let's jump into this problem. As you can see, we have two racing car A and B, and we are asked to determine the relative velocity and acceleration of racing car B with respect to A. So when you can see this problem, racing car A and B are traveling on a circular portion of a racetrack. Racing cars are very important for a computational purpose, and they are prepared for a computational purpose. They have a very fast speed with, as you can see, it has 162 km per hour. It has 144 km per hour. It is very large distance that covered by a car within a hour. So they have a very fast distance, and they are prepared for computational purpose only. As instance shown, the speed of it is decreasing at a rate of 7 meters per second square. Here we have a racing car A, and it has a speed of 162 km per hour, and this speed is decreased at a rate of 7 meters per second squares, and the speed of B is increasing at a rate of 2 meters per second square. Here we have a speed which has a velocity of 144 km per hour, which is smaller relative to A, which is 162, and this speed of B is increased at a rate of 2 meters per second square. So here we are given the acceleration of racing car A and B, which is minus 7 meters per second square and 2 meters per second square respectively. For the position shown here, determine the velocity of B relative to A and the velocity of B, the acceleration of B relative to A. So in order to determine the relative velocity and acceleration of car B with respect to A, first we must use the concept of resolving of vector, and we can resolve the vector of racing car A and B into its components, which means the vector of A, which means the accelerations and the velocity of racing car A and racing car B. Then after resolving the vector into its components, we can use the formula and collecting like terms, and finally substitute the value, and you will get our final answers. So first we can use the concept of resolving of vector, then we can use substitution. Resolving of vector means the splitting of vector into its component, which has the same effect as original vectors. So in order to determine the first problem, or in order to solve the relative velocity of B with respect to A, we can use the formula velocity of B minus velocity of A, which means the relative velocity of B with respect to A equals to the component of velocity of B minus the component of velocity of A. As you can see, the velocity of A is moving in this direction at an angle of 30 degrees. Here we have 60 degrees, which means 120 degrees. Sin theta are positive for quadrant 1 and quadrant 2. We can use alternatively 120 degrees or 60 degrees. Then 40 meters per second is the unit conversion for 144 km per hour. Simply by using a unit conversion factor, 1 km per hour is equal to 3.6 meters per second square, or 36 over 10 meters per second. We can convert 144 km per hour and 162 km per hour, and we get 14 meters per second and 45 meters per second respectively. So after this, we can substitute the value. Here we have 14 meters per second times cos 45 I minus sin 45 j minus 45 cos 45 times cos 120 degree I, or 60 degree I minus sin 120 degree j. Then we can collect the like terms. You have in the x component, and we have in the y component. You have use the concept of vector additions and subtraction in order to add or subtract a vector. After resolving the vectors, it is very simple. We can add or subtract a vector that have the same coordinates, and for vector multiplication of vector with two different types of vector multiplication, scalar and dot product. Scalar product and vector product of vector multiplication. We are familiar for this concept. So after substituting this value, you will get 5.7 I and minus 67.25 j. after this.